Hi everyone, my name is A, and today I would like to talk to you about exploring double integral over general regions. So, this is an essential tool in calculus for computing the area, volume, and other quantities over two-dimensional regions. It also extends the concept of single integral to integrate functions of two variables over general regions in xy plane. It means for single integrals, the region over which we integrate is always an interval, but for double integrals, we want to be able to integrate a function f not just over rectangles, but also over regions D of more general shape. So it has types of regions called type 1 and type 2. So these type 1 and type 2 regions are a classification used to describe the boundaries of regions over which double integrals are evaluated. So let's look at each type. For type 1 regions, its definition says, a plane region D is of type 1 if it lies between the graph of two continuous functions g of x and h of x. It means the region is enclosed by the curves that can be represented as functions of x. And when we draw vertical lines parallel to the y-axis, they intersect the region at most twice. Its formula can be defined as if f is continuous on a type 1 region D, then double integral over a region D of a function f of xy dA is equal to the integral from a to b and integral from g of x to h of x f of xy dy dx. So this is the type 1. Let's look at type 2. So for type 2 regions, its definition says, a plane region D is of type 2 if it lies between the graphs of two continuous functions g of y and h of y. So it means the region is enclosed by the curves that can be represented as functions of y, g of y and h of y. So like the type 1, so when we draw horizontal lines parallel to the x-axis, they intersect the region at most twice. So for type 1, we draw the lines parallel to the y-axis, and for type 2, we draw the lines parallel to the x-axis. So its formula can be defined as, if f is continuous on type 2 region D, then double integral of D f of xy dA is equal to integral from c to d and integral from g of y to h of y f of xy dx dy. It has many applications in various fields, including physics, engineering, economics, and probability. And it is used to calculate mass, center of mass, moments of inertia, and surface areas. So in conclusion, the type 1 regions are bounded by functions of x, and type 2 regions are bounded by functions of y. Let's look at it again. So the type 1 regions are bounded by functions of x, and the type 2 regions are bounded by functions of y. So this is a powerful mathematical tool for calculating various quantities in two-dimensional space, and understanding the types of regions and the corresponding integration techniques is important for effectively applying double integrals in problem solving across different domains. Thank you everyone for listening to my presentation. I hope you have a good day.